Hello everyone and welcome back to the channel. In this video we are going to repair this PCB. It's an SMPS power supply for a Samsung split air conditioner. Model number is AQV12NSAN and the model number is DB93-05866A. This might be a revision, as I have seen that there is a B and C version of this PCB. This one is actually dead, and as with any SMPS power supply, we're going to start from the fuse, which apparently is not this one. This is where the power input is. Our fuse is actually, let me get my plastic stick, right here. So as you can see, we have obvious marks of damage here, here, there. We have two bridge rectifiers, one here and one over here, and the whole other part is the logic microprocessor that does all the other jobs. As you can see, input runs here into this EMF coil, inductor, whatever it is, and goes here where the switching happens. Now I'm going to remove some of the parts to give some space for the bridge rectifier, the SMD one right there. And as you can see, we definitely have a damaged part over here, probably a resistor, as I can see from the, I think it's R106. So what I'm going to do, I'm going to desolder some parts. As you can see, I don't know if it is possible. There seems to be some damage on the power IC, just where the part number is. These are very common among house appliances. It's a TNY2 something. We will take a look on it later. Now this can be a DIY job. It is a bit intuitive. Now for the IC, if you don't have a desoldering iron, you can just cut all the legs with the side cutters, remove the pins with a soldering iron from the holes, and clean the holes with a desoldering wick. I'm going to start my desoldering station. You might hear the noise as well, it's quite loud. Now let that heat up. Oh, we need to take some measurements first. So here is our multimeter. I'm going to take a measurement between the legs of the pins of the capacitors. As you can see, we definitely have a short circuit there. and there. Now this bridge rectifier, the big one, the through hole one, seems to be okay. Now let's check this IC, which definitely looks damaged. This should be the drain and the source part of the IC. Let's test between those 2 points. And sure enough, we have a short circuit. Let's start removing parts and see what part is the shorted one. There may be more. Oh, we should also check the fuse. And as you can see, the fuse is open, so blown. These are just one-time use. You throw it away and put a new one. Let's start desoldering. I'm going to remove the IC. I'm going to remove also the transformer, just to have a bit of more space there, and this coil that we're going to test to see if it is open or damaged. Let's remove the IC first. As you can see, some pins are hard to desolder because they have a big copper section on the side. I'm going to add a bit of solder to flow them again, and hopefully now, oh yes, nice, here as well. It doesn't budge. That's one way to remove it. Now let's check again if we have a short circuit between those 2 pins. And it looks that it is gone. Let's check our bridge rectifier here. No, I cannot reach it. So I'm going to remove the capacitors and the coil and maybe the transformer here. Add a bit of solder from the start. So both of these are 6.8 450 volts 85 degrees capacitors. Let's check their condition. That's a bit high, but it's a bit normal for such a small capacitor. Let's check the other one as well. I don't have a contact there. Oh wow, move it to different pins just in case. So this one is definitely damaged, just 100 picofarads. Wow. So yeah, this is done, and maybe that's the reason the power supply failed. I mean, Samsung caps are known to fail. Let's also remove the coil right here. Let's test our coil. This is 502. Let's see if it is open, and it should be able to measure coils. And sure enough, 6.5 millihenries, 15 ohms. So this coil is good. Now we definitely have to remove our blown fuse. There we go. Okay. It's a 1 amp 250 volt fuse. And also the resistor I was talking is right here. I'm going to give it just a bit of a clean there. Oops. Some rubbing alcohol. So that looks like a 0605 part, probably a resistor. We may be able to find that from the service manual. Now, in order to see if we have any more damages, I want to measure the bridge rectifier. I will put my multimeter in diode mode. I don't know if I can see the markings there, but this looks like negative. It goes here, so this should be positive. So we go on the positive, the negative probe, and the other two, and there we go. This is our first diode. Second diode is okay, and now we put our plus probe on the minus and check the other two diodes of the bridge rectifier. This one is okay, and this one is okay. So actually our bridge rectifier is absolutely fine. This is, no, I don't get good contact. Oh, this is shorted. This must be a TVS diode, so we have to remove that as well, as it looks shorted. Let's get the multimeter out of the way. I have to open the tip a little bit. So this is quite a big part. So here is our part. I cannot really make the marking. We will check it later. Let's see if the short was caused by the TVS diode. And no, that's interesting. So there must be a short somewhere else. Oh, this goes between 2 points of the transformer. Let's check the diode here. So actually what I was measuring was the pins of the transformer there. Let me give this a clean. Okay, so I guess this might be fine. We're going to replace it anyway. I'm going to see what we do about that. Now there is another SOT 23 part there. Just I'm going to check in diode mode if there are any shorts there. Nope, just to see if there is one diode there, maybe like that. No. This doesn't look shorted. So that means we have to find the IC first of all, which is damaged exactly at where the two numbers are for the part number. Also we need to find this here. Definitely both capacitors and maybe the diode here. Everything else looks alright. We have to order our parts and take it from there. Here we are. All our parts have arrived. We were lucky enough that Samsung provides a service manual that includes all the individual parts of the PCB. So this one is a 4.7 kilo ohm resistor. We can find it from the designators here, R106, if I can see it correct. And this is, and I want to correct it from before, an 0805 resistor. So SMD resistor. Sizes are 0805 or 06 or 3. I will replace all the electrolytic capacitors, although they may have not failed yet. It is a good practice in order to keep it from coming back. Now for someone that does not have a desoldering iron, you can gently hit each pad and lift a bit the capacitor from each side. You have to do it a few times, so I don't know if we can see it. I'm warming up the leg and pull gently, same from the other side. Here one pin, and there we go. You don't want to force anything, just gently liquidify the solder and pull the capacitor. Now, in order to unblock the holes, just use some desoldering wick and as you can see, our holes are open again. I will go ahead and use the desoldering iron just to save some time. It's a bit noisy, but it will do the job. Just out of curiosity, let's check the capacitor that we have removed. So this is a 470 microfarad 16 volt capacitor. As you can see, it's well inside its tolerance, so this capacitor measures good. ESR is low as well. Now let's go to the next one. This one is a 1000 microfarad 25 volt one. And this one also measures good. Let's go ahead and remove this vertical one. This one is a 220 100 volt one. Oh, this one is a bit low, but still within tolerance of 20%. Generally speaking, the higher the voltage you go on the capacitor, the tester will measure it on the lower side. Let's go ahead and remove the last one, this one here. This one is measuring good as well. Now, I said that this is a bridge rectifier carried out with the symbols underneath, but actually this is a solid state relay, so it is definitely not bad, as it is not a bridge rectifier. Now let's also remove our tiny resistor there. I will just add some solder, as it may have welded itself. As you can see, it's not easy to remove. Okay, there we go. Wipe the soldering tip. Give it a good clean there with some pure alcohol. So the pads look intact. There doesn't seem to be any other damage there at all. Also, using the Samsung service manual, we were able to find that this is actually a TNY266P part number. Let's start placing our parts here. We will start with the smallest one, which is the resistor. I will use my wick to just make it a bit flatter for the new one. So here is our resistor. Let's try the other side. There we go. Hold it up there. One side is good. And now I'm using my thin 0.5 solder to have just a bit better control. Our resistor is on there. Don't know if you can see. Let's go ahead and continue with the other parts. We have our fuse, just turn off the desoldering station, we don't need it anymore, and of course tin the tip. Here is our fuse. Here's our side cutters. There we go. Generally speaking, you want to go with the lowest in the height parts first, and then with the bigger ones, in order to have good access. So put our resistor back into place. Now we have the TNY. Goes straight in there. There we go. looks it had flowed well. And now we have our input filtering capacitors and the coil. I also got a replacement for the TVS diode here. It was most probably okay, but just to be on the safe side, I bought a replacement one. So let's place that there as well. We can use our tool to bend. Still, this does have an orientation mark, the cathode here, so that's how we install it. This is done. Now our coil goes right here. The hole is a bit closed. I will just use the soldering iron just to help it a bit. There we go. Down, so I will use now the other one, the other hole, and try to get this through. There we go. All the way in. Soldered very nice. Now our high voltage input caps, 6.8 microfarad, 450 volts. There we go, very nice. And now let's replace the rest of the capacitors. Here was the 220 100 volts capacitor. Wherever I can, I go with the Panasonic FRs. They are just the best capacitors with low ESR, high ripple current and 10,000 hours. Compared to 1,000 hours that most standard capacitors are rated for. Of course, the rating is together with the temperature, so this has 10,000 hours at 105 degrees. The ones on the PCB were 85 degrees Celsius, as you can see. So the rating would be for the 85 degrees. Here goes the 470 microfarad. I didn't have a 16 volt one. We can go up when replacing capacitors within reason. So we went from 16 volts to 25. The only thing we should take a look is the ripple current that the higher voltage can withstand. Now here is our 1000 microfarad capacitor. That hole is also blocked a bit. I will help. There we go. And we are actually ready. I cannot find my connector. I definitely had one like this, so I'm going to make one and give it a try. So in order to make a cable for this, we need this connector, which is this one. Yes. And a couple of these. Oh, I forgot this one. All right. This is a bit long, but we should be okay, I think. Put the cable. And crimp. There we go. Oh, I crushed it. Look at that. Let's start over. Here is our cable. Now let's replace the capacitor I forgot. Here is the last one, and now we are ready for testing. Here is our test setup. What I have done here is I have a 100 watt lamp in series. Don't know if it's very easily. So light goes here through the lamp into the PCB, and the neutral comes back here to the cable. This is just to connect the ground to the circuit. Because I don't have the display LCD which has the on-off button, although I am almost positive that it is this connector, but what we can do is check the voltage at the regulator. So if you have a 12 volt, that means that our SMPS power supply here is working properly. The purpose of the lamp is that if we have a short, we will not blow something up and the lamp will stay lit. I will use a couple of wooden blocks. Be careful that this may have live voltage on it. I have used a ground from here. It's the same thing as the middle pin of the regulator, and I have my socket here. I will try to briefly power the circuit for a few seconds, being careful that our wires don't touch anything, and then I will take the measurement. So power on, and power off. We are smoke free, that's a good sign always. And now let's bring our multimeter here in DC volts and connect it to our regulator. Here is our cables. So that's much better. Power on again, and we get nothing. Okay, power off. Let's troubleshoot it further. I did a little bit of poking around and I noticed that actually this is not the input. One pin, if we check the bridge rectifier, is connected there, but the other one isn't. And actually here is the pin that is connected. Both of them go through this common mode choke. So I'm going to, good thing we didn't damage anything, I'm going to give power here. It also goes through this fuse, and give it again a try. So we have one connection for the bridge rectifier. Sorry, we have one connection here and the other one here. I have used this wire to connect to this point. The other one is like it was before. Now let's run our smoke test again and give power for a couple of seconds, and then we will power it on normally. Now let's try again. The power supply is power cycling. It might be because of the lamp. Now let's give it a try without the lamp connected, and same thing. Here we are back with this split AC PCB. Unfortunately, I couldn't find anything wrong with the PCB. I did check the optocouplers here. I did check some components on this board, but because I didn't remove this and I have no idea how it is connected and if the other circuits play a role for it to start up, it would be easier to give it to the customer, so we will get some feedback from there. I couldn't make something from the schematic provided in the service manual. Here is the schematic. We will have to wait for the customer to give us his feedback, and see you then.